We've been talking a bit about motion, so now it's time to put some numbers on that motion. Physicists use two quantities, speed and velocity, to talk about motion. Both of these quantities describe how quickly an object is moving through space and time. Speed and velocity and math are what allow us to talk about how quickly race cars move, how fast any object moves, and how long it will take you to get to the moon if you travel at 15,000 miles per hour. That's fast. So let's get down to business. Speed and velocity are both rates of change in position with respect to time. So what's the difference? First of all, speed is the distance with respect to time, whereas velocity is displacement with respect to time. Since distance is a scalar, this means that speed is also a scalar, so it has magnitude but no direction. Velocity, on the other hand, deals with displacement, so velocity must be a vector. Therefore, it has magnitude and direction. When you say distance with respect to time or displacement with respect to time, you are setting up a division problem or a fraction. You must divide the distance by the change in time to get speed. This is written as S for speed equals d for distance over t for time. You have to remember, though, that d is the change in distance and t is the change in time. These little triangles are the Greek letter delta, which signifies change in. Velocity, on the other hand, is the displacement over the change in time. This is written as v for velocity equals change in x for position over delta t for change in time. Generally speaking, motion is the change in position over the change in time, which is written like this. In most cases, speed and velocity are measured in meters, a unit of length, per second, a unit of time. A rocket ship traveling at 15,000 miles per hour is about 6,700 meters per second. That's very fast. This is the same as crossing 73 football fields from end zone to end zone in 1 second. Achieving such high speeds wouldn't be possible without physics, and marveling at such high speeds wouldn't be possible without speed and velocity calculations. Now let's talk a bit about instantaneous and average speed and velocity. The instantaneous speed of a car is what is measured by a policeman's speed gun. It is the rate of change of the car's position over an infinitely small period of time. This is awfully hard to calculate because it's tough to figure out how far the car moves in an infinitely small period of time, and it's even harder to divide this distance by an infinitely small period of time. Instead, we'll work on measuring average speed and velocity. Let's talk about how to find an average velocity. The average of a set of numbers is the middle of the road value. Let's say that my car drives 10 meters per second for 3 seconds, and then it drives 20 meters per second for another 3 seconds, and 30 meters per second for the last 3 seconds. Let's find out its average velocity. First, we need to know the total distance that the car travels. In this case, that's 180 meters. We'll learn to calculate this later. Second, we need to know the total the total time that the traveling occurred, which in this case is 9 seconds. We set up a fraction like this, and then divide. Here we can see that 180 over 9 is 20, so the average speed, or velocity in this case, is 20 meters per second. If this is a velocity calculation, we have to specify a direction. Let's say that the car was traveling 20 meters per second east. Wow, we're speeding along. Next up are some practice calculations. Bye for now.